All right, here we go. We've got an example here with three different examples. So again, we want to look for two squares. So this is the difference of two squares, right? So this is a squared minus b squared. So in this case, a is p, right? And b is 10. And so the way we would write this would be p minus 10, p plus 10. Now whether I wrote the plus here and the minus there doesn't matter. Okay. Now here, this one we've got to do one set because notice that there is a common factor here of 2. Yeah, so 2. So if we factor out a 2, that gives us 16y to the fourth minus 81. Now we can see that we've got two squares, 16 and y to the fourth and 81. So here the a would be what? 4y squared, and the b here would be 9. And so we would write this, now don't forget your 2, so the factored form would be 2 times 4y squared plus 9 times 4y squared minus 9. And that would be it. And then finally, if we look at this third example here, we've got another common factor. So let's factor out the z. So we get z times 625 z to the fourth minus 1. Now, you might think, oh, well, this is not a difference of two squares. But, got to be careful because this 1, remember 1 times 1 is 1. So we could put a square here, right? We could treat that as a square because 1 times 1 is 1. And so what would we do? Well, now we've got two squares. So I didn't change the problem at all by putting a square here because, again, 1 times 1 is 1. So now I've got a square here, so this a value would be what? Well, the square root of 625 is 25. And then z to the squared. And then, of course, this would just give me 1. And so this is going to be z times 25 z squared plus 1 times 25, that's an x. Should be z. Z squared, so z squared minus 1. And there you go. So again, you just have to remember the form when you're dealing with the difference of two squares.